Okay, boys and girls, we will continue our lesson. Okay, this is lesson 40. Last week we already learned a bit, and then we got continue with few past year questions, but we still have another two more questions. So today, before we start, we do some revision, okay, revise a bit regarding the IV characteristic. Okay, um, we got Ohm's law, follow Ohm's law, then we say that this component actually is ohmic conductor. If it doesn't follow Ohm's law, then we will say this is non-ohmic conductor. Okay, basically, if ohmic conductor, how we know? Ohm's law. We know that Ohm's law is R equals to V over I. Okay, so this R actually is the gradient. If you plotting the IV graph, you will get a graph like this, directly proportional. Okay, you'll get a graph directly proportional. Directly proportional meaning that it's a straight line passing through zero. Okay, so what is the definitions for Ohm's law? If you do more past year question at here, you will find that they were asking you, hey, is that the Ohm's law? So at here, current is directly proportional to V. So if you put the graph I and V, current is directly proportional to V. So when you're plotting the gradient, okay, you're plotting the gradient. So at here, you will get I over V. So you found out that resistance actually is 1 over gradient. You need to upside down. Okay, so Ohm's law actually is R equals to V over I. They're plotting the graph I and V, but actually you want to be opposite the axis also, never mind. You can be say that V is directly proportional to I also can. Okay, so this is Ohm's law. So if the conductor they follow Ohm's law, they will should be getting a graph straight line passing through origin. Okay, so if we come back to here theory, the first one, okay, resistor, this resistor or maybe metal wire, okay, if after we plotting the graph we found out that it's straight line passing through origin, then we say that this conductor actually follow Ohm's law. Okay, Plaza message me, but let me have a look. Can we just use the symbol instead of the word? Yes, yes, yes. For the Ohm's law, for the definition, no, it's not a good idea. You're just using the symbol. No. Okay, so at here, gradient, I thought just now Prasan asking about this one, can we using symbol? My answer is if you want to using symbol, yes, with the unit, don't forget graph is with the unit. But if for the definition for Ohm's law, don't using symbol, okay? Don't using symbol. You have to write in words. Okay, so if the conductor is a straight line passing through origin, so we say it follow Ohm's law. Okay, you see? Obey Ohm's law. So this resistor actually is ohmic conductor. It will having a constant resistance. No matter you draw your triangle at here, or you draw your triangle at here, or you're using a bigger triangle, at the end you found out that the calculation for the resistance part, you will get the same answer. So this is constant resistance. The resistance doesn't change. Okay, here. Obviously, this one is not a straight line passing through origin, so we understand this is non-ohmic conductor. Okay, what is diode? In year 11, we learn, okay, or from 5, we learn in the electronic chapter. Diode actually is a component helping us to convert AC to DC. AC to DC, if input is AC like this, they got a two half cycle, positive and negative half cycle. So the AC at here, this is AC, okay? Wait, AC. We need to convert it into DC like this, or actually full wave, half wave, doesn't matter, okay? Convert to from AC to DC. Okay, why we need to do so? Okay, we learn about transformer. We understand that transformer only works well with the AC. Okay, keep on changing direction, then alternating magnetic field. Okay, then transmitted the electricity to our house. But the problem is our handphone charger, our laptop, all these charger maybe we are using DC. So our house coming 240 volt is AC. The electricity that we receive is AC, but we cannot directly use AC for our device, which is the needed DC. So how should we do? We need a component called diode. Okay, diode function is AC to DC, convert AC to DC. How it convert? If in the correct direction, I allow current to flow. Okay, let's say this one. So when current, if let's say flow in the same direction, you look at my triangle. I teach my students how to remember. You see this diode, okay, the triangle, and the current triangle direction is the same. Then yes, you are forward bias. I allow the current to go, okay, because we are in the same direction. So let's say this is the correct direction of the current. So output, I will allow current to flow. But if let's say you are in the opposite direction, then I will block it. So at the end, I can use diode helping us to rectify AC. So can you see that this part? Okay, if it's in the wrong direction, no current can flow. So let's say current flowing in this direction. It's oppose our symbol of the diode. Okay, from here, this one, I is here. So diode will block it. Why it block? Actually, it block is because your diode is connected in reverse bias. Okay, when reverse bias, the diode resistance will become very high. So this one, resistance will decrease. If forward bias, resistance will decrease. Okay, then teacher, how do we know about the resistance? At here, you see the graph is not a straight line. That means that your gradient is not a constant gradient. Of course, your resistance will not be constant. Okay, just now this one is a straight line. So this is a constant gradient, constant resistance. But at here is a curved line. Okay, so I teach you, we draw a triangle. But of course, we no need to draw a complete. We also can compare. So for me, I just draw a line to showing the stiffness of the line. You see, stiffness. Okay, steeper. Which one steeper? Okay, here obviously this one at the end is become steeper line. Okay, steeper line. So at here, gradient, we understand R equals to V over I. Gradient in this graph, IV graph, is opposite. So if I want to compare resistance, actually the gradient, I should 1 over the gradient. So this one steeper line. Steeper line, that means higher gradient. If higher gradient at here, your resistance decrease. So can you see this curve graph? Actually, the resistance is decreased when current is flowing in the correct direction. If current in the opposite direction, diode in reverse bias, this one totally no current. It block it because resistance too high. This kind of shape, please don't trying like, teacher, can I just memorize? This is not a good idea how you study physics. We should understand, then we should interpret the graph. Instead of memorizing, okay, we need to understand. We understand when they are in forward bias, diode in forward bias, okay, it allow current to flow, meaning that resistance is low, decreases. Okay, resistance in this graph is 1 over gradient because it's I over V at here. 1 over gradient. So that means I want lower resistance. If let's say I want lower resistance, that means that my gradient should be increases. That's why you see at the end we get a higher gradient. Okay, so this is about diode. Okay, for diode, normally they will have some minimum voltage required to trigger it lah. Okay, it not necessarily must be 0.6. It can be others value. It depends. Okay. Okay, so this is diode. Then after that, this is the lamp, filament lamp. Okay, I already told you this is filament lamp. Okay, inside here, the filament actually is made from tungsten. Why made from tungsten? Because tungsten having a highest resistance. Okay, higher resistance. So at here, when your voltage increase, V increase, okay, V increase, so your current of course will increase. Okay, like for example, you provide more power supply, then your current of course will be higher. Okay, when current higher, the temperature of the filament lamp will increase because when current flowing through resistant wire, heating effect will be produced. So today, one of the subtopic we were talking about how heating effect is producing. Okay, current flowing through the resistant wire, heating effect is produced. So temperature will increase. Okay, the higher the temperature, the higher the resistance. So in year 11, we learn about factor affecting resistance. We say that it affecting by the length, affecting by the area, affecting by the temperature, affecting by the material. Okay, this one year 11 we learn. Of course, Form 5 we're also learning electricity. So at here, when you are higher temperature, you will get higher resistance. So in this graph, it will be different as just now. Just now is curved upward like this. Okay, right now it's curved like this. Okay, what is the difference? You will find out that the gradient at here, actually this part, the gradient is reduced. Not that steep compared to the starting point. Okay, not that steep, less steep. So gradient decrease is because this one less steep. When gradient decrease, then your resistance will increase. For the filament lamp, from time to time, temperature will increase, resistance will increase. So at here, actually resistance increase. Okay, when you are doing the experiment about the electricity, we always remind the students. So boys and girls, please, when you are not taking any reading, please open the switch. So guys, you doing the practical, you also need to remember about this, okay? Because you're doing practical and then let's say it's electricity. When you are adjusting something or you are plotting your graph or whatever what you do, okay, you are not taking the reading from the circuit, please open the switch. You do not letting the current keep on flowing through the circuit, okay? It will producing heating effect. For us, maybe we don't notice it, okay? We cannot feel because it's not that high temperature increases, okay? But in the whole circuit, it might be increase the, it producing the heating effect, increasing the temperature. Then at the end, your resistance and your result will be not that accurate, okay? So this is the reason current flowing through the resistant wire, filament lamp, it will producing heating effect, temperature increase. Okay, so at here, we already done for this part, Okay, then we comes to the page number 7. Okay, question 1 to 3, we done last week. Okay, here, just now I got mentioned to you. Wow, teacher, should I memorize? No, if you understand what is Ohm's law, you no need to memorize at all, dear. Right? Okay, you see, I and V, axis. Actually, these two axes can be changed. So if your answer is current is directly proportional to the potential difference, 1 mark. 1 mark. Or you want to say potential difference is directly proportional to current, also correct. 1 mark. But another one more mark is you need to mention mass, okay? Provided that temperature is constant. Okay, temperature for the conductor doesn't change. Why? Because this graph, what it want to represent? It want to present the resistance. And resistance, it will also affecting if your temperature is changes. Okay, so we want to compare, we want to use this graph provided others physical quantity must be constant. So we need to mention, okay, provided the temperature is constant. So not only this question, here later on, we got. I go through for maybe next lesson, next worksheet. Okay, so at here, this is a quite common definition they want to ask. No need to memorize, but we're using the concept here to explain. That's all. Okay, here, the variations of current I, this one I, with potential difference V for the filament lamp. So this case is filament lamp. The resistance will change, will increase. So filament, when voltage increase, the resistance will increase. Increase with potential difference, resistance will increase. Okay, state how the figure 5.1, how you know? How you know that resistance increase? Okay, any of you can tell me, or you type your answer, tell me. From the graph figure 5.1, how it show that resistance increase when the potential difference increase? Try, think, and then tell me. Manjo, let me have a look. Gradient, but explain more, dear. Manjo. Prasan, gradient get less steep. Gradient increase or decrease? Decrease, yes. gradient becomes smaller. Well, correct. Okay, so for me, I will say resistance is equals to 1 over the gradient. From this graph, actually, it's 1 over the gradient. So the gradient of our IV graph is decreases. So when your gradient decrease, we understand that resistance increase. If gradient decrease, resistance increase. Yes, they're correct. From the graph, how we know? Because the gradient decreases. From the graph, how I know resistance increase is because, you see, if I draw the line, here draw the line. Can you see that this line is less steep? Okay, so the gradient actually is decreases. The gradient is decreases. So the gradient for this graph actually is 1 over R. So if you want to find the resistance, actually is 1 over the gradient. Gradient decrease, so your resistance increase. So from the graph, I know is why resistance increase is because the gradient of IV graph is increased. If let's say, I don't want to say others, let me think. Okay, if let's say, now the case is here is IV. So graph is like this. Okay, if let's say we change, now it's because VI. How was your graph? Okay, increase your resistance. Actually, your graph will be like this. Okay, can you see that here? I draw the line. Here I draw the line. So this one gradient increase. Your resistance is V over I. In here is increase. So if they change the axis, your graph will be different. Okay, so you cannot just memorize the shape, cannot. Okay, question might be changed. So if like this, same question, then they're asking you from this graph, then how we answer? Because gradient is V over I is actually resistance. Gradient increases. Gradient of the VI graph increases. Okay? So next, explain why resistance change in this way. Why resistance will increase? Explain why. Okay, they say that when potential difference increase, resistance increase. So we answer when potential difference increases, what will increase? Current will increase. Then just now I got mentioned currents flowing through the resistant wire. What effect will be produced? Heating effect. Okay, heating effect. Temperature increase. Yes, very good. When heating effect produced, then temperature will increase. Okay, so current increase, then heating effect is produced, then temperature increase. Then when temperature increase, then resistance increase. Okay, so we got few steps. So current increase 1, then temperature increase 2, then resistance increase 3. 3 things have to mention. Okay, I add one more heating effect is because why current increase, temperature increase is because produce heating effect. Okay, 30 seconds for you to complete this pair. Okay, done? Can we proceed to the page number 8? Fatima okay, Vashini okay. Okay, Wesley okay. Just now in the WhatsApp group, I sent out the last week video recording. For those who absent, please study back. Okay, page number 8, question number 5. The variations with potential difference V of the current I for the resistor X. Okay, resistor X, you see, this one is a straight line passing through origin. So this is a ohmic conductor. Okay, and it will having a constant resistance. And for the semiconductor diode, okay, for this one, can you see that the minimum voltage it needed to trigger to activate it is actually 0.2. It's starting from here. More than this 0.2, it only allow current to flow. Okay, determine the resistance for the diode for a potential difference 0.6. Okay, when 0.6 V here, 0.6. So you read out what is the current and then how you find resistance. Resistance V and I. Can you find it out? V equals to IR. You got the V, find your I. Okay, then find your R. Do calculation and then tell me. Oh, very good, Prasan. Because you didn't trick by the question. You gotta read all the things carefully. Good job. How about others? Vashini, correct. Good. Any others? 0.6. Power correct. Yes, power correct. Jore correct. Okay, good job. Dio, you all very good. Okay, V equals to IR, your resistance. Okay, or you want to using R equals to V over I also can. Okay, so 0.6 divided by 7.5. I worry you will stop at here, but so far all the answer that you given to me all are correct. It's because you are good. It's because you got pay attention now. What is the prefix or what is the unit? So milliampere. Milli is actually times 10 power of negative 3. So times 10 power of negative 3. So my answer at here I will get 80 ohm. Okay, 80 ohm. Is that clear? Okay, describe qualitatively the variations of the resistance. Okay, qualitatively means that the characteristic, the nature of the resistance. Okay, variations of the resistance of diode as we increase from 0.6 to 0.75. Okay, when voltage 0.6 to 0.75. 0.6 to 0.75, this part, can you describe what happened to the resistance? Somewhere here, this area. Vashini, correct. Good job. If you didn't refer just now the graph, you try using your understanding answer this question. That means that you get the idea already. Fatima, correct. Good job. Hassan, correct. Okay, dear, here and here. So this one's steeper line. Gradient increase. Then ask yourself, gradient in this graph is I over V. So this one increase, but this is not resistance. Resistance should be V over I. So in the opposite way, it should be 1 over the gradient. So gradient increase, resistance should be decrease. So somewhere here, actually resistance decrease. Okay, so here, when voltage increase, resistance decrease. Okay. Done. Then we are going to proceed to, we do practice. Wait, before we goes to the thermistor and the what and the LDR, we goes to page 12. There we do the page 12 here. This question is related with what we learned. Okay, do not refer. Do not refer to the just now the notes. Can you, using your understanding, trying to answer what is this? Is this a filament lamp, conductor, resistor, or this is a diode? What is your answer? Hasan, good job. Answer should be A. Answer should be A. Because resistance increase. From the graph, resistance increase. Gradient decrease because less steep. Gradient decrease and then resistance is 1 over gradient. So resistance here increase. So this is filament lamp. If diode, resistance should be decreased. If these two, it should be constant R. Okay, then we go to the next page here, number 5. Okay, try, this is page number 13 try and then tell me which A, B, C, D, which one has the greatest resistance? Wesley, correct, good job. Fatima, no. Here resistance is equals to V over I. So they draw VI. That means that you can compare using the same V. Using the same V. Then you compare. Fawal, yes. Manjo, yes. Dear, you look at this, okay? Here, when we using the same V to do comparison, then the resistance will be affecting by your current. Here, we are not comparing how their resistance change. We're not comparing how resistance change from starting to ending. We are not comparing itself. We are comparing A, B, C, D. So we want to do comparison, then we take the V, same V here. Okay, same V, but then D at here, it having the lowest current. Here, if your current is the lowest, mathematics, one number divided by a small number, your resistance here will be high. So answer should be donkey. We don't using just now the technique that I teach you about this and this. That technique is I compare itself from starting to ending how resistance itself changes. But now we are comparing these 4 conductor, how their resistance when across it is V1, when their voltage is the same. Okay? So Fatima, get it? Let me check. Okay, dear, number 6. Can you try? IV characteristic for 2 components P and Q. So which statement is correct? When current is 0.5, power dissipated in Q is double up. Okay, can you try? Power, we got 3 formula. P equals to VI, or P equals to I squared R, or P equals to V squared over R. So at here, you have to think, what formula for P you can use to do calculation? What was the number Prasan asking? Prasan D, yes. Prasan D, correct. Okay, number 6. What formula you can use to do calculation so that you can know that AB, which one is the correct, or CD? So boys and girls, can you try and then tell me what is the answer? Wesley, correct. Wesley, did you do some calculation? What formula you use? Power, correct. Hey, not bad. Washini, correct. Prasan, correct. Washini, good job. Yes, correct. You using I square R, Wesley. Then you have to calculate the resistance. How? Manjo, correct. Okay, so dear, here, can you see that? We got I, we got V. Then we're using P equals to VI is the most easiest one. P equals to VI. Okay, then at here, when 0.5, current is 0.5. So at here, my V is 2. So at here is 2.0 times 0.5. I will get 1 watt. So this is P. Power for Q is VI. When 0.5, so I will get 4.0. So here, 0.4.0 times 0.5, I will get 2 watt. Okay, so can you see that PQ over PP is 2 over 1. So it's double, correct. Answer should be A. Okay, answer should be A. I know it's A. Can you explain why C is wrong? Okay, no problem. Resistance of Q increases as the current increases. Okay, Q at here, dear. Q. Is it resistance increases? Prasan, this line, can you see that this line actually is steeper line? Here, this part, steeper. That means that your gradient higher. Resistance is V over I. So in this graph, actually, it should be 1 over gradient. So when your gradient increases, your R should be decreases. So this one, Q, it should be decreases, not increases. Okay, so B, why B is wrong? Okay, in 1.9, the resistance of Q is half that of resistance of P. You see, 1.9 is somewhere here. Somewhere they are touching, having the same V, having the same I. So what is their resistance? They should be almost the same. Should not be half. It's almost the same. Because can you see that this point? Both components having same voltage, having same current 1.9. So for B, answer should be the same, not half. Okay, resistance at this point, R equals to V over I. Same V, same I at this point. So it should be the same. Okay, then this one, is it a fixed resistor? Yeah, P fixed resistor. But is it a Q? Is a filament lamp. Filament lamp, you should be increase your resistance. But this one, the Q actually is decrease resistance. Filament lamp, resistance should be increases. So here wrong. In the graph, actually, it's showing you resistance decreases. So A, B, C, D. Until here, is that clear? Clear, then give me response, then we can proceed. Okay, then we go to the next page. Okay. A fixed resistor and diode are connected in series. Okay, in series. So series, always remember series current will be the same. To a battery of EMF 6.0 volt, negligible internal resistance. What is this? In future, we will learn next chapter. The graph shows the variations with the potential difference V of the current for the diode. So this is the IV graph for the diode. The current in the diode is 40 meter ampere. What is the resistance for this? Okay, so from here, what information you can get? From here, what information you can get? Then after that, how you solve, and after that, how you find resistance? Can you guys try? Wesley, no. Try again. We got two components right now. Please make sure you are talking the correct component. Any others? Let me have a look. Manjo. Manjo, correct. Yes. Vashini, correct. How about others? This is roughly 1.2 lah, because here is 1.25. So roughly 1.2. Okay, so voltage here is 1.2 volt. But don't forget what is the question asking. Fawa, correct. Good job. Fatima, no. Fatima, no. So check which part you make mistake. Okay, dear, here I want to emphasize. This is for the diode. The information that we get is about diode. Wesley, correct. Is it you using the 1.2 to do calculation? Prasan, correct. So here 1.2, here 6 volt. So we are share the voltage because this is in series, voltage is share. Or we say component connected in series, actually they are potential divider. They share the potential difference. So this one, it should be 6 minus 1.2. It will receive 4.8 volt. Question asking you fixed resistor. It's not asking you diode. So we need to read the question carefully. V equals to IR. It received 4.8 equals to the currents 40. Don't forget the prefix times 10 power of negative 3 times the resistance. So your resistance should be 120 ohm. Answer should be B. I'm not sure you give me answer A. Is it you using 1.2 to do calculation? Let me check. Yeah. So please read the question carefully what they are asking right now. Okay? So if no question, we are going back to talk about thermistor and LDR. Is it okay? Fatima okay already? How about others? Vashini okay? Baba okay? Manjo okay? Okay, good job. Okay, so we need to come back here talking about thermistor and LDR. Okay, these two device actually most of the time we will be connected with the resistor, okay, acting as a potential divider. Okay, we learn this in our IG and SPM, potential divider, share the voltage, okay? So we will using connect it in the circuit to trigger the circuit, we detect the environment condition, okay, situations. So for the thermistor, it will be affected by the temperature and normally used for fire alarm system lah, okay? So this is the symbol, you have to know the symbol, okay? Then after that at here, when temperature increase, resistance will decrease. This is the characteristic for the thermistor. Okay, so at here we can add some point how it works actually. Okay, number one, when temperature increase, temperature increase. Okay, so the what thermistor will release more electron. Okay, release more electron. Release the electron. So electron is the very important in our conductivity. So if you have more free electron, that means that your conductivity is very good. Easy to conduct electricity. Okay, so our conductivity will be increased. That means that it allow more current to flow. It allow more current to flow. So more current to flow at the end, what does it mean? Okay, meaning that your resistance will decrease. So here, temperature increase, resistance for thermistor actually will be decreases. The resistance will decrease. Why? Temperature increase, we can release more electron to flow. more electron can flow, that means that is a better conductor of electricity. Okay, better conductor. So when we are allow more current to flow, that means that resistance become lower. So this is how we get the graph. Temperature increase, resistance decrease. Okay, so at here, when low temperature, then the resistance will become high. When high temperature, then resistance will become low. Their relationship actually is inversely proportional. One high, another one become low. Okay, until here, is that clear? Fatima, okay. Washini, okay. Okay, good job. Then we talk about LDR. LDR is a sensor for us to detect the light intensity. Okay, light intensity. So can you see that the symbol is actually the arrow pointing in? Why in? Receive the light. We detect the light intensity. So we need to detect, that means that we receive it. Okay, so don't make mistake with the LED. LED is something like this. Okay, this is diode. But if I want to make LED is light emitting diode, emitting. So that means that go out. So here, this one is actually going out. For LDR is we receive the light intensity. So the arrow is pointing in. LED is pointing out. Okay. And then some more, can you observe? This one, LED and thermistor, actually their basic structure is a resistor. And then we add this one and then add the arrow. So basically, these two sensors is actually one type of resistor. Okay, they are a type of resistor. Okay, here, same thing. When light intensity increase, resistance will decrease. Okay, here, why does it happen? Okay, number one, when light photon hit the LDR, okay, so they provide energy to free the electron, okay, to let more electron coming out. Okay, so at here we are increase the charge carrier. Charge carrier is the electron, okay, charge carrier. Charge carrier is proton or electron, okay, but the one can move in the circuit is actually electrons. Okay, number three, so when you're having more electron to flow, your resistance is decreased. Okay, if you are graduate from SPM, photon is a package of light. Okay, one package. Okay, so when the light hit the LDR, actually they will provide the energy for LDR to release the electron. Okay, so the more the electron you have, the more it can conduct the electricity, so the resistance will decreases. So at here, light intensity increase, your resistance will decrease because more free electron is released out. Okay, so at here, when that environment, resistance become high. Okay, when bright environment, resistance become low. Wesley, let me have a look. Charge carrier. Charge carrier is the proton or electron. But at here, the charge carrier that I want to mention is about electron. Because in our electricity, the electron is the one that can be moved. Charge carrier is the carrier bring the charge. It bring the charge, so it can be proton or electron. But here, I want to mention about the charge carrier. Actually, I'm mentioning about electron. Because in conductivity, the circuit can works or current can be flow is because electron. Is it okay, Wesley? Okay. So done. Then we try with the partial question right now. Okay, let's go. A cell of negligible internal resistance is connected in series with the thermistor. A fixed resistor, okay, in series, always in series, then ask ourselves, same current, okay? So let's say we got a power supply, then we got the thermistor, then we got a fixed resistor, then it got the ammeter. Okay, something like this. Thermistor is placed in a beaker of water and the temperature increase. Okay, so this one temperature increase. So a graph of current against T of the thermistor is plot. Okay, so just now the graph that we learned in our worksheet, the notes, there is talking about resistance and temperature. Right now it's talking about current and temperature. Okay, temperature increase. Which graph is correct graph? A, B, C, D. To represent I with T. No, dear. Wesley, no. Just now here is resistance. Resistance. This is resistance against the temperature. Now is current. So Wesley, ask yourself, when temperature increase, what happened to your resistance? Then what happened to your current? But at the end, your answer is correct right now. You know why, dear Wesley? You already understand the concept? Fatima, correct. Pawa, correct. Yeah, correct, Wesley. Vashini, correct. Okay, so dear, our answer should be B. Okay, so here temperature increase, resistance for thermistor will be decreased. So your current will be increased. In A, B, C, D, all are decreased. So they all are wrong. They are decreased. Only B is increased. So only B is the correct answer. Okay? So goes to question number 2. The intensity of light incidence on the LDR increase. Okay, so it's in bright environment. So at here, temperature increase in each case. So this is two separate case. The current maintained at a constant value. So in each case, they're trying to maintain the current. Okay, so what happened to the potential difference? So for this one, we know that resistance for LDR, light intensity increase. LDR resistance should be decreased. This is what we learned already. Temperature increase. So thermistor resistance should be decreased. What happened to your V? And some more, they tell you I is constant. What formula you use and do comparison to observe what happened to the V? What formula can relate? And then to compare. When R decreases, what happened to your V? Wesley, correct. How about others? Fatima, no? Later on you check. Manjo, correct. Washini, correct. Okay, dear, here. You see, got V, got I, got R. So we're using this formula to do comparison. When we want to compare, you see, when we want to compare about what happened to the R and V, please make sure your others physical quantity must be constant. You cannot say that I want to compare R decrease. At the same time, my current also become increases. So at the end, what happened to your V? Cannot. When we in the formula, we trying to find R and V relationship, others physical quantity should be maintained constant. That's why in this one, they mention current remain at constant value. So this one is constant. So they will be affected by the R, V, they are directly proportional. So when your R decrease, your V should be decreased. Fawa, correct. So just now at here, light intensity increase, resistance decrease. Why? Here, just now at here. LDR, okay, light intensity, more light at here, okay, 0 at here, this one maybe whatever, 100 or what. Resistance become lower, so resistance decrease. When resistance decrease, your voltage or potential difference will decrease also. So your answer should be A. So resistance for LDR decrease, resistance for thermistor decrease, so your V will decrease. So Fatima, do you able to get it? Get the idea? Oh, you wrote A. You wrote A. Yeah, you wrote A. A is a wrong. Oh, sorry, dear. Answer should be D. Oh my God. Answer should be D. When resistance decrease, V decrease. Because at here, resistance decrease. I'm so sorry. D. So Fatima, D, do you get the idea? Mashini, yes. Thank you. Okay, dear, next. A car has a sensor for detecting the light intensity and temperature of the environment. The sensor makes use of LDI and thermistor. The car moves from warm and dark environment to cold and bright. So this is our latest environment. So we just focus at here. Cold and bright environment, what's going on? What happened to the resistance? This one very straightforward. Answer. Wesley, correct. Okay, cold, that means that you see here, temperature. So this is resistance. So it will be curved like this, right? Okay, so when cold environment, this one is like low temperature. So you will find out that the resistance is very high. Okay, high out. So resistance should be increased. So for the bright environment, also the same. Your light intensity, then this is your resistance, is inversely proportional. So at the end, when bright. Oh, wait. Yeah, correct. Bright environment is somewhere here, bright. Okay, bright somewhere here, resistance actually become low. Decrease. Wait. Did I make something wrong? Okay, this one is LDR because light. This one is temperature, is thermistor. I know. Okay. Thermistor. Okay, dear. LDR here. LDR is actually here resistance decrease. LDR resistance decrease. Thermistor resistance increase. So answer should be C. Okay, in the question they talk about the temperature first, but at the end in the table they talk about LDR first. So please this is careless mistake I I will do careless mistake also. Okay, C Manjo, yes. Okay, dear, we goes to here. Okay, for this one last week we learned about resistance. Can you tell me A B C D, which one will give you a total resistance with 100 ohm? Without using a calculator, you also can tell me one. Because last week I did teaching you about the shortcut way to calculate. Any of you? Prasan, correct. Do you guys still remember that I told you that if two resistors, their value are the same, we can using shortcut method to do calculation. For example, this one, okay, they are in parallel and then some more same value. So your resistance for this part can be 100 divided by how many of them? 2. So here is 50 ohm. 50 ohm series with this 50 ohm. So you get 100 ohm. Your answer is B. Okay, if you want to do calculation for others, for example, this one, you cannot using shortcut way. You should using the 1/100 plus 1/50, then reverse it. So this is a part for this. Then if here, teacher, can I using shortcut method? No, because here is not the same. So if you want to do calculation for this one, resistance, you should 1/100 plus 1/100 plus 1/50, inverse it. Last one easy, just in series, add it up, 250 ohm. Is that clear? Yes or no? Okay, Washini, okay. Fawa, okay. Fatima, okay. Okay, dear, this one. Try to use the shortcut way I did teaching you. This one, each resistor have a resistance 6 ohm. That means that all of them are the same. Resistance are the same. Can you try using the shortcut method? But of course, you want to using the very long method, 1 over, 1 over, 1 over. That one also never mind. Question number 2, do calculation. Wow, very fast. Good job, Wesley. Correct. Vashini, correct. Okay, so 6. All is 6 ohm, 6 ohm, and 6 ohm. How many of them? 6 over 3. So it's 2 ohm. This one, 1, 2, 3, 4, 5, 6. So this part is 6 over 6 is only 1 ohm. Then this one is 1, 2, 3. 6 over 3 is 2 ohm. Okay, so at here, 2 ohm in series with 1 ohm in series is 2 ohm. Answer is B. If this is a structure question in paper 2, if let's say this is a structure question, so most of the time we will say, oh, 2 plus 1 plus 2, then I get 5 ohm. This is not a good idea. 1, 2, at least 2 significant figure. Of course, we're not writing 5.00. It doesn't bring a meaning. What? Okay, so at here, can you see 1, 2, 2 significant figure? Okay, question number 3. Fatima, correct. Okay, number 3. Can you do calculation? What is total resistance is 120. What is your resistance R? Rasan, correct. Only person get the answer? How about the rest of you? Oshini, correct. Okay, deal. Look at me, this one. If they are in series, that means only one path. In series is one path. So you have to decide whether it's a series or parallel. Manjo, correct? Okay, so at here, look at me. This is one path. One path. So my finger go, there is no other path for me to go. So it's one path. That means that R, actually they are in series. Okay, so they are equals to become like this. Become 3R and R. So 1 over R plus 1 over 3R, inverse it, you get 120. Okay, so this one is times 3 times 3. So you get 4 over 3R. Then upside down. So when I upside down, become 3R over 4 equals to 120. Your R should be 160 ohm. R should be 160 ohm. Is that clear? Okay. Okay, dear. So this one settle. Okay, settle. Okay, we goes to your lesson number 41. we goes to your lesson number 41. Why my worksheet become like this? Is it I'm sending the worksheet like this to you? What is this? Did I sending such worksheet to you? Oh my goodness. Oh, yours one okay. So it's my problem. Well, let me check. Oh, okay. Just now maybe the file corrupts or what? Okay, here. Resistivity. Okay, resistivity. All the material having their own resistance. So just now we got mentioned, resistance, when the current flowing through the resistant wire, it will produce heating effect. Okay, why? Okay, now we learn. Okay, so at here, all material have their own resistance. Okay, for the flow of charge, for the to resist the current to flow lah. Okay, flow of charge is the electron. Here, charge that we mentioned is about electron because only electron can flow. Okay. As the free electron move, they will collide with the vibrating ion. So this is the vibrating ion. Okay, this is the vibrating ion. We're not calling it as atom is because it's loose electron. Okay, so it become ions. So at here, electron is the small one is the electron. So the electron moving. So when they move, they collide. Move, they collide. Move, then they collide. Okay, when they collide, the electron will transfer some of their kinetic energy to the ion. So this ion, when they gain the energy from the electron, so they will vibrate more, okay? Faster vibration. So faster vibrations, that means that your kinetic energy for the ion is increased faster. Okay, so temperature is actually directly proportional to the kinetic energy, average kinetic energy. So if they move, vibrate faster, then temperature will be higher. That's why the resistance will cause the heating effect. Resistance resists the electron to flow. So not easily for the electron to pass through, so the electron will keep on colliding. When collide, they will transfer the energy to the ions. Ions gain more energy. Ions will vibrate more. Vibrate more, it will increase the temperature because temperature is directly proportional to the kinetic energy, average kinetic energy. So at the end, temperature higher, it producing heating effect. Okay, so that's why overall we will say when current flowing through resistance wire, heating effect is produced. Okay, we got a few factors affecting the resistance. This one we learned before, but we recall okay? The length. So if let's say this is a longer conductor, this is a shorter conductor, but their area is the same. Okay. So how it affecting the resistance? You can imagine this is you trying to play some game and you have to pass through the game. Okay, pass through and play the game and win the game. So this one is the path that you have to go through. Okay, then at the end, this is a shorter path. So which one actually not easy for you to pass, go out at the end, using a shorter time to finish your game? Actually, the longer one, you take more effort. You have to put more effort to pass through and then win the game. So for this one, the length, when the length increase, actually not easily for you to pass through. So it will be higher resistance. Current will be lower. Okay, so this one if shorter, then opposite way lah, resistance can be decreased. So this is the length. So you imagine you are going to play the game. So this is the game to resist you to pass through. Okay, so this one is longer. That means that you have to go through with a longer distance. Okay, area. Okay, my notes at here is something wrong. The bigger the area. Okay, let's say at here, the area is big. This is small area, but same length. Can you see that? If I compare the length, my area must be the constant. If I compare the area, my length must be constant. I cannot like this one change, area change, length also change. Then how do we compare? So just now I say V equals to IR. If I compare the R and V, then others physical quantity must be make it constant. Here the idea also the same. I compare the length, area must be constant. I compare the area, then my length must be constant. Okay, so imagine this is the hole you're playing the game. When the area is bigger, you will be more easier to go through because the hole is big. Okay, so resistance is low because you easy to pass through and then end the game. So this one current will increase. So for the bottom part area decrease, then your resistance will become high, current will become low. Okay, sometimes they're not using the word of area, they were using the word of diameter. Greater diameter, greater radius. Something like that. Or they say thick wire or thin wire. They talk about thickness. Okay, the bigger the area, actually this one is wrong. It should be lower the resistor. The resistance value should be lower. Okay, then for temperature, just now we say that V and I, their relationship is directly proportional. So provided temperature does not change, it's because temperature also affecting. So temperature is something like this, the graph. This is temperature. This is the resistance. Even at 0 degree, some country maybe in the winter season, you cannot say that the wire 0 degree Celsius, it don't have resistance. No. So for this graph, it doesn't start from 0 here. Because even 0 degree Celsius resistant wire still have resistance. Okay? It still have the value for the resistance. Okay, type of material. It depends on the type of material. Okay, few type. Tungsten, nichrome, copper. Different type of material, they were having different resistance. They were having different resistance is different. Okay. Then because of 1, 2, 3, okay, 1, 2, okay, we can combine and then we get a relationship. Okay, so at here, R is directly proportional to L. Then this one is R is inversely proportional to A, or we say directly proportional to 1 over A. You get what I mean? So this one, if let's say this one is R, here is A. I know that the greater the area, the lower the resistance. But I cannot form a formula for the inversely proportional. So what should I do? I should get a directly proportional graph. Okay, so what should I do? I make one A become 1 over A. A become 1 over A. Then I will get a graph of directly proportional. I combine these two formula. We will get the formula at here. R is directly proportional to length over A. We want to form an equation. We should make the directly proportional become equal. The symbol equation in symbol is equal. But I cannot put R is equals length over A. I should add a constant value. Okay, constant value for it. At here, the constant value we call it as resistivity. This is called resistivity. Okay, different material will have different resistivity. How we derive the ohm meter? Actually, this one easy. You just rearrange the formula RA divided by length. R is ohm. A is meter square divided by meter. So it will become ohm meter. This is unit for resistivity. Not memorizing, but we are understanding how we know the unit. Okay? So at here, we get this formula. By the way, you should familiar with this formula lah. Okay. Can we proceed to the next page? Washini okay, Wesley okay, Fatima okay, Anjo okay. Okay, here The higher the resistivity, the higher the resistance. Okay, so resistance and resistivity, they are directly proportional. Same material, same resistivity. Sometimes they don't tell you that same material. They say that, oh, first I using copper wire. The length is like this, diameter is like this. Then after that, a second copper wire I use, copper wire and copper wire. Then we automatically understand this is same material. Then we need to understand the resistivity is the same. Even they didn't provide the resistivity, actually we can just cancel out their resistivity because they are the same. Okay, here, oh, one more thing I want to emphasize at here. In your A level is, teacher is the same like what we learned in Form 5 and IG. Okay, here, slightly different is, at here, the area they won't provide to you directly, okay? Area is, we know that is pi r square, right? So most of the time, they giving the diameter instead of they give you the radius. So diameter is pi d square over 4. Okay? Pi d square over 4. Okay? Mark it down. Then here, come here. A wire of resistance. Write down, this is R. Diameter is D. Resistivity. Resistivity is a symbol like the density, you know, like this density symbol. It's the same. Okay, can you calculate what is the length? Oh, Wesley, very good. Correct. Machine, correct. How about others? Okay, this one actually is just apply for, oh no, area. Yeah, area. So area, it should be pi d square rho L. Okay, if you do it correctly, your answer should be A. Here is Fatima, correct? Here is they giving you diameter, so you need to find the area. For me, can you see that I apply area pi d square over 4 inside the formula for R? Then after that, because divided by this, the 4 actually become moving up. This is mathematics, it's not physics. Rho L divided pi d square over 4 actually is rho L times 4 over pi d square. Mathematics, this is mathematics. So at the end, 4 resistivity times the length divided pi d square. Oh, where's my square? Here. If you do it correctly, you should get 1.20 meter. Any question? Any question? Okay, no. So we proceed to the question number 2. Okay, the iron wire have a length L. So this one is iron, length L, diameter is D, resistance is R. So this one is length 1, D1, R1. Second iron. Okay, can you see that? Iron. iron, and then this one also iron. That means that they're having same resistivity. Okay, so this one is L2. This one is D2. Okay, normally when they're asking you what is the new resistance, what is the new in terms of the first one, so I will always using ratio, because ratio can cancel out some value. We no need to count a lot of value, we can just cancel out. Okay, so at here I will do calculation for R1 equals to rho L1 A1. Or at here, because it's diameter, so it becomes 4 rho L1 pi D1 square. This is R1. R2 is 4 rho L2 divided by pi D square D2 square. Okay, for the first one, R1, 4 rho, we don't know. L1 is 8 divided by pi D 0.5 times 10 power of negative 3 cube. Square, not cube. Okay, this one is 4 rho L2 is 2 divided by pi D 1 times 10 power of negative 3 square. Okay, why I say that I like to using ratio? We always got such kinds of question in whatever chapter, in calculating the polarization, in calculating whatever. They like to asking you in terms of second, what is the new in terms of the first one. So I always like to using ratio is because some of the value, we no need to just times it up, do calculation, we can cancel it out. So for example, at here, second one over R1. So your second one is 4 rho times 2 divided by pi 1 times 10 power of negative 3 square. You divide the R1, divide R1. So at here, divide 4 rho 8 divided by pi 0.5 times 10 power of negative 3 square. Okay, that means that it will become times pi 1 times 10 power of negative 3 square upside down. Pi 0.5 times 10 power of negative 3 square divided by 4 rho 8. You see, some of the value actually we can cancel out at here. We don't need to press calculator. Okay, I means that we don't need to press a big value, calculate a lot of value. Okay, for that. Here, resistivity doesn't giving to us, is doesn't matter because they are same iron. So the iron, so their resistivity is the same. Pi and pi can cancel out. 4 and 4 can cancel out. Then after that, you just press your calculator like this. Okay, or you want to simplify again, 1, this one is become 4. Then you calculate it and then you tell me what is the answer. Now I doing until this step is because I want to tell you how to solve such kind of question. Okay, it always come out in whatever chapter, not only like this chapter, others chapter also they were asking some questions, something like this. The best way for me to solve is I using ratio. Okay, ratio to solve it. Washini correct. Prasan correct. So at the end, R2 over R1, R2 over R1, I will get 1 over 16. So R2 equals to 1 over 16 R1. What is my R1? Just now at the top, I say is R, resistance R. So R2 actually is 1 over 16. Okay, I know that actually we don't need to do such detail. But I do such detail is I worry some of you don't know why I suddenly upside down. I can skip if your mathematics is good. Okay, you know why I upside down, why I suddenly become like this, then it's fine. Okay, but here I do in more detail to show you why upside down is because here divide. So I become times, I need to upside down. Okay, if no question, we go to your next page. Fatima, okay, okay, good job. My dear, here. They give you question number 3, give you the length, give you the diameter, give you a graph. So what is the resistivity? Formula R equals to rho L over A. They're asking you what is the resistivity. Did they giving you the length? Yes. Did they giving you the area? No. But we can do calculation by using the diameter. Then they didn't give us the resistance. How can we solve? Where can we find the resistance? From the graph at here. Why? The gradient, 1 over gradient, not gradient, 1 over the gradient actually is our resistance. Okay, or you find, yeah, you do it by yourself. From the graph, find the gradient, 1 over the gradient, that is your resistance. Correct. Correct. Okay, resistance at here. Let me check. Vashini correct. Wesley correct. Fatima correct. Manjo correct. Manjo no CC. Is C. Okay, here. Okay, let's say at here 5 over 10 is your gradient. So you get 0.5. 1 over the gradient actually is your resistance. So your resistance is 1 over 0.5. Actually, you should get 2. Oh. So here 2 equals to 4 rho, I don't know. The length is 0.8 divided by pi d. D is 5 times 10 power of negative 4 square. So if you do it correctly, your answer should be C. Okay, your answer should be C. So it seems like we're still using the same formula like our IG and SPM, but at here, they like to giving you D diameter. So we need to apply the area equals to pi d square over 4 inside the area. Okay, so next, this question. This question come out for at least like 2 times. I saw the past year question. Okay, an electrical cable is made up of one thick string of copper wire that is surrounded by X thin string. Okay, all 9 strings of the wire connected in parallel. This question I guide you. Later on behind got one question, similar question. That question, then you try by yourself. Okay, so this question I guide you. So when they are connected in parallel, each thin strand of the wire has a cross-sectional area A and length is L. Thick one is 4A and then the length is still the L. Total resistance is R. Okay, here. When they are connected in parallel, so we can calculate using 1 over R plus 1 over R plus 1 over R, then inverse it, right? Okay, at here, we can solve for the thin one first. Because the thin one, their characteristic all are the same. That means that the thin one, they having the same resistance. Okay, so for the resistance for the egg wires, okay, they are using their resistance. We don't know. We just put a resistance value first, okay, the R. So they can divide it by 8. Shortcut way. Okay, total we got 8 connected in parallel way. Then I simply give a symbol first, okay? So let's say each of them is R. So R over 8. Okay, then resistance is rho L over 8A. Resistance is rho L over A. Okay, so this one is resistance for 8 wires. What is your total resistance? Okay, total resistance is actually we are 1 over the 18 wires plus 1 over the 1 thick wire. Right, because they are in parallel. But I solved the 18 one first is because they're having the same resistance more easier. I just solve it, okay? But then I cannot solve using shortcut way with the thick one is because they are different, okay? Then after that, 1 over your total actually is 1 over your egg wires, thin wire plus 1 over thick wire. Okay, so at here, 1 over rho L over egg A plus 1 over rho L over A. Oh, okay. The area for the thick wire is 4A. The wire here for the thick wire is 4A. Okay? Rho L over A. Then after that, upside down, okay? A over rho L plus 4A over rho L. So I got total is 12A over rho L. This is rho 1 over RT. So your RT upside down again, rho L over 12A. Right? So rho, what is the resistivity? Rho is 12 total A divided by the length. Okay, what is your total resistance? Your total resistance is actually the giving symbol of R. Okay, so your 12 RA divided by L. So your answer for this question should be donkey. Okay, this question, I guide you like this and give you the concept. So behind got one question similar. I want you to try it by yourself. Let me check where is the question. Page number 7. Can we turn to your page number 7? Okay, this one you complete first. The idea is we can using the shortcut way to find the resistance. But I need to separate because egg is thin, one is thick. I cannot just combine all. So I settle the egg thin one because they're having same resistance, same area, same length, so it will be same resistance. Okay. Then after that, I find the total. From the total there, I include with the resistivity formula. So I will get the rearranged formula only, mathematics. Okay, page 7, question number 1 actually is a similar question. Not really similar, but the idea is there. Okay, can we proceed to the page 7? Fava, okay. How about others? Fatima, okay. Manjo can? Jore? Manjo, okay. Ashini, okay. We goes to page 7, page 7. Okay, you see? Electric cable consists 7 strands of copper wire. Each diameter is 0.3 mm and connected in parallel. Connected in parallel. So it's the same idea like just now they connected in parallel. Resistivity, they give it to you. Then the current, they give it to you. What is the potential? From here, we straightly saw I and V. So that means at the end, we are going to applying V equals to IR. But before that, since V and IR, we want to find this one, what is your V? That means provide your current. That means that this one out, you should have the value. But how? You see resistivity. So that means that from here, first step, you have to count resistivity. You have to count resistance. But from the resistance, how you count? You're using the formula of this. Then after that, you find your R, then you're using V equals to IR to solve the problems to find your V. Can you try it? One meter apart. So this is the distance, the length of the point that we want to observe. You find your R, but this is R is for one copper. When you calculate your R, this is for 1 only. When resistivity is 1.72 times 10 power of negative 8, when the length is 1 meter apart, okay, the area you're using pi d square. So this is the d, pi d square. So this is not yet a total resistance. You still need to find total resistance. Then you only can apply this formula. Manjo, correct. Hey, good job, Manjo. Good. Don't forget you calculate your R. The value all that you're using, the length, the area is for 1. Now you got total 7. They connected in parallel. Wesley, no. Fatima, no. Try again. Prasan, yes. Washini, correct. So, dear, this one is 4 rho L over pi d square. So, 4, 1.72 times 10 power of negative 8. L is the length. Length is 1 meter apart divided by pi d. D is 0.3 times 10 power of negative 3 square. Okay, if I do, my answer is 0.2433 ohm. Don't forget, this is a resistance for 1 wire, 1 copper wire, only for 1. But what is your total for 7 strands of copper wire when they connected in parallel? So your total resistance should be your R divided by 8. They are the same. They are copper wires. Each of them same diameter, then same what? The same length. Wesley, correct. So at the end, you should divide it by 8. That's why I told you shortcut way to calculate resistance when they are in parallel, same value. So this is very important. 0.2433 divided by 8. Oh, 8. 7. 7. Sorry, it's 7. What I say 8? 7. So my answer at here is 0.0348 ohm. V equals to IR, total V, total I, total T. Current in the cable. No, okay. Here, the total. Okay, here. So let's say this is the... So they all already combined. They are parallel. Okay, so at the end, you already combine them. So become like this. Okay, become like this. So your current is 13, your total resistance 0.0348. So your answer should be 0.45 volt. Answer should be C. Electric cable consists 7 strands of wire. Cable is 13 ampere. So this is total current. This is total current. Cable consists 7 wire. Cable current is 13 ampere. So it's total current. Is that clear, dear? Okay, Fatima, okay. How about others? We want to go back to page 4. Okay, Wesley, okay. Vashini, okay. Okay, page 4. This one is a good question because it's related with just now what I mentioned. When they asking you about the graph, we always trying to find the formula and then make sure, let's say for this one, I compare R and L. So I need to have a formula which is relate R and L, and others physical quantity must be fixed, must be constant. Okay, so for this question, okay, what is this? The resistance. Okay, talking about resistance, so we learn resistance is rho L over A. Okay, so if I want to compare the L and the R graph, okay, that means that this part must be a constant, cannot change. So I only can compare what's going on with your L and R. But the problem is, in this question, they say that same volume is the same. Okay, but then they goes to different length. When volume is the same, volume is actually the area times the length. Am I right? So when your length is already changed, your length increase, actually your area also keep on changing. It will keep on change. Okay, it will keep on changing. So the A is not a constant. I cannot straightly compare R is directly proportional to L. So B is not our answer. We will think that B is our answer, but no, cannot. Why? Because R is directly proportional to L provided your resistivity and area is the constant value. Then I only can say R is directly proportional in this case. But because same volume but are using different length, if your length change, your area also change. Volume is area times the length. Your area keep on changing when your length change, then your area keep on changing. So that means that I cannot straightly compare using this. I should try to do some substitution and make the physical quantity is constant other than the L and A. Okay, so how we do that? Okay, volume is constant. So at here, area is what? Area is actually the volume divided by the length. Am I right? Okay, volume is area times the length. So area is volume over length. So at here, resistivity length over the area at here, I trying to make it here volume is the same. So volume divided by length. Volume divided by length. So at here, if we upside down, rho L over V times L divided by volume over L. So the L become go up. So you will be R is equals to rho L square over volume. So boys and girls, we ask ourselves, is it this part is a constant right now? Okay, resistivity is constant. Of course, this is the constant resistivity. Resistivity is constant. Volume is also constant. So this part is constant value. Now I can compare your length and your R. Now I can compare your length and your R. So your length and R right now, R is directly proportional to your length square. Directly proportional to your length square. For this question, they're changing the length, they're changing the area. We cannot straightly from the formula, initial formula, then we deduce that resistance is directly proportional to length. For this case, it's different. Different length, different area. So we need to think how we need to substitute and change the area to something constant value. So we found out that constant volume, then we're using the volume divided by length. Then divide, so become times, so I need to upside down. So at here, R is directly proportional to L square. This in your mathematics, your graph should be donkey. Okay, this one, this formula, directly proportional in your mathematics, your graph shape should be like this. This kind of question often come out, not only for this chapter. They test on you, your idea. Do you know how to make others physical quantity as constant variable? Then we only compare this and another one. So we have to think how to change the one, keep on changing one to become a constant physical quantity. Okay, until here, do you guys get my idea about this question? Question 5. Washini okay, How about others? Fawa okay, Fatima okay. Get the idea why I need to do so, because area keep on changing, so cannot have to make it become a constant. Okay, next. The resistance of a metal cube. Cube, that means that same side, okay? That means that something like this. Okay, this one L, L, L. This is cube. Okay, here the cube has a volume V. So volume is actually L times L times L. L cube, okay? And a resistivity, the connection to the cube have negligible resistance, so we don't care about this part. Okay, which expression give the resistance of the wire meter cube between X and Y? Okay, so we understand resistance is what? Rho L over A. Rho, they already giving to us rho. Then L, L is the length. But it didn't give us area. So what should I do? It didn't give us area. Okay, you look at this answer, from here answer, can you see in terms of volume? In terms of volume, there is no involving with length, so no involving with the area. So what should we do? You have to think how L explain, how you express the L in terms of V. In terms of V, okay, how you give the L in terms of V. So V is equals like what I say, L cube. So L is actually V1 over 3. Power of 1 over 3. Okay, so if area actually will be length times length, so it will be volume 2 over 3. Do you agree about this part? What is your L in terms of V? Okay, can you proceed the rest? According to the question, only involved with resistivity and volume. So we have to think how to make L in terms of V, how to make A in terms of V. Actually, same idea like just now. How to make A in terms of volume and length. Okay, can you proceed and then tell me your answer? Okay, so at here row, the length V1 over 3, the area is volume 2 over 3. So at here, mathematics solve it. Rho, then divided by 3 minus 1 over 3. So it's actually rho V1 over 3. So answer C. Any question? No question. Good job. Wesley, okay. So we proceed to the page number 5. We proceed. Fatima, okay. Proceed page number 5. You see Ohm's law again, asking you. Just now the previous worksheet also asking you about Ohm's law, right? You see. Current directly proportional to potential difference or vice versa. That means that if you change, say that V is proportional to the I, also correct. But don't give V and I lah. You write in the words, okay? Provided temperature is constant. Okay, here a battery of electron multi-force 6.2 and negligible internal resistance is connected in the circuit. In a uniform resistance wire, voltmeter is fixed at here. Okay, the resistant wire has resistant acting ohm. Okay, this wire have 18 ohms. Then length is 0.94. Cross-sectional area is 7.2. So this one, A, this one is the length. This is the resistance for the wire. The slider S is positioned halfway. Halfway. So can you calculate? First question asking you to calculate resistivity. Quite straightforward, dear. Do it right now. First question is quite straightforward. You can solve it. Wow, correct. Wow, correct. Vashini, correct. Fatima, correct. Yes. Wesley, correct. Okay, dear. At the end is 1.4. This is two significant figure. Three significant figure also correct. Times 10 power of negative 6 ohm meter. 1.4 times 10 power of negative 6 ohm meter. Okay, the switch is open. The switch is open. That means that if they open, we don't need to care about this part. If they open, we don't need to care. So, next, what they say, state the reading of voltmeter. What is this voltmeter reading? Where is their position right now? Slider S is positioned halfway of the length. So what is this voltage? Is it? Voltmeter reading. Ignore the bottom part because the circuit is open. So any of you can tell me what is the voltmeter reading? Do I need to do calculation? Varshini, good job. You understand the concept. How about others? No, Wesley. Half. You see, the wire for the voltmeter is connected at the half of the resistance wire. Half. Okay, dear. If I connected like this, I connected all the part. So the resistance should be the voltmeter here should be 6.2 volt. Fawa correct. But now the question is, Wesley, now the question is like this. Half connected some wave here, here, half of it. So 6.2 volt at here become half of it. So this part, half length. The length become half, that means that it will receive half of the volt. So here also receive 3.1 volt. So for your voltmeter pointing at the half, so it will receive 3.1. Get it? If the voltmeter place at here, there is no resistance here. If let's say okay, points at here, so your voltmeter will show 0. Okay, then start to have potential meter. Our year 11, we learn potential meter. Fatima, correct. Okay, get the idea? Then we goes to your patch number 6, dear. Patch number 6. The switch is now closed. So I close the switch. State whether there is an increase, decrease, or no change to your current in the battery. That means total current. current in the battery, that means that total current. What happened to your total current? Okay, so we come back to here. Right now, the switch is closed. You can ignore the voltmeter. Sometimes voltmeter is like, it will make us like confused and think more. But it's okay, actually. We just take it out. Voltmeter is just a device for us to measure the potential difference. Okay, for example, like this. Then I got another resistance connected at here. Maybe half, like this. Okay, so you can ignore the voltmeter. Okay, dear, here. What happened to your total current? What do you think? What happened to your total current? Any of you got the idea? Total current. I give you the hints. What happened to your total resistance? If from know this to becomes having this in parallel way, what happened to your total current? Wesley, no. Wesley, no. Okay. Changes from here to here. What happened to your total current? Okay, let me check Fatima. No. Washini, correct. Jory, higher or lower, Jory? Increase or decrease? Hey, Jory, they're asking you whether there is an increase, decrease, or no change. Okay, dear, initially, when the switch is open, so we ignore this part. We can also no need to look at the voltmeter is because voltmeter is just a device, measuring device only. So at here, starting our circuit is like this. After the close the switch, so this is our new circuit. What happened to your total current? Okay, first question asking you what happened to your total resistance. Yes, okay, Wesley, correct. Because when you connected something in parallel, dear, connected in parallel, what's going on with your resistance right now? In parallel, in series, we will add it up together, so it will become higher resistance. But in parallel, we will always find out that your total resistance, your resistance at this part, actually, there will be decreases. Then your total resistance, okay, total resistance will decreases. So your total current in the battery can be increases. It can be increases, dear. I repeat one more time. Because here, this part, we are connected in parallel way. Your total resistance will be decreased. Let's say 6 ohm, then parallel with 6 ohm. What is your resistance for this part when they parallel? Become 3 ohm, 6 divided by 2. So it becomes smaller. This part resistance, when they connected in parallel, they will decrease the resistance. Then you add it up this one, overallly, actually, you will be smaller resistance than here. Because this part, they will decrease the resistance already. Then resistance, total resistance decrease, total current increase. So your answer for this question, current should be increased. Why current increase? Because total resistance decrease. Why total resistance decrease is because parallel. There is a parallel circuit there to reduce down the resistance. Okay, what happened to the voltmeter reading? Any of you know? What happened to the voltmeter reading? When your resistance decrease, this part resistance, when this part resistance decrease, what happened to the voltmeter at here? This part resistance decrease. It will get more share or less share. You can assume this is a potential divider. So this part will get some voltage and here will get some voltage. But because on my left hand side, my resistance decrease is because they are in parallel. Then after that, it will get more share or less share. Wesley correct. Washini correct. Fawal no. Okay, so here okay, this part. If let's say after you combine, this part it becomes lower resistance because they parallel. Then after that, this one is still the same. So here lower resistance, it will get more share or less share. They will get less share of voltage. It will get a less share of voltage. I can give some example, simple example, like this. Okay. Let's say this is 6 volt. Here is 2 ohm, here is 4 ohm. Total current 6 divided by 6 ohm, so it's at 1 ampere. How many volt will be received by the 2 ohm? It will be received 2 volt. How many volt received by 4 ohm? It will be 4 volt. So can you see that this potential divider share the voltage one? When your resistance decrease, your voltage that you share will be decreased. Okay, this concept only for potential divider. When the component connected in series, we only can apply this concept. Okay, 2 ohm only receive 2 watt, 4 ohm receive 4 watt. So for this one, just now, when the close the circuit, this part resistance actually become lower because parallel. When resistance become lower, the voltage is share will be decreased. Of course, voltmeter that we connected at here, the voltmeter will showing a decreased reading. Is that clear? You can ask question before I proceed. Fatima, okay, I get the idea. Vashini, okay. Wesley, okay. Fawa, okay. Okay, dear. So here, this one, it should be decreased. Okay. The switch remain closed. The slider S is moved along the resistance wire so that the voltmeter can be maintained at 3.1. Just now, we already say it will less than 3.1 already. Initially, without close the switch, this position, it will give us 3.1 volt. But after we connected with this parallel resistance, we found out that this part voltage was less than 3.1. Because this part and this part parallel resistance decrease, it will get less share. So it will get less than 3.1. Okay, now the question said that it moved the slider S so that the voltmeter can go back to 3.1. Where should you move? Possible new position. Please draw a close. Where should you put your slider S so that you can maintain back the 3.1? Where should I move? Move to the left or move to the right? Think and then tell me. Fatima, correct. Wesley, if you move to the left, so here this one resistance, small resistance, parallel with another resistance. So your resistance decreases, more decreases. The voltage decrease. So boys and girls, what is the correct way is we should make our part, this part, the resistance higher so that it can get more share. So where should we move? Since we put at here, it get less than 3.1 volt, then I need more. I need more resistance. So I should move my sliders to the right, S here. Somewhere here. So that I get more resistance. Overall, I can increase my resistance. Is it Wesley? Wesley, do you get the idea? Okay, good job. Any others? Manjo? Do you able to follow, Manjo? Okay. Right there here. Circuit B is changed. We change the battery for one a different EMF. The switch is open. So a student record, okay, a student change the battery and then open the switch, then get the current. So this is the current, this is the speed, this is the number of density of charge carrier. So this one is actually the N. What is your charge Q? So our previous lesson, we learned I equals to NAVQ. This is a formula. Okay, your current at here, they say 0.93. Your N is number density is 9.0 times 10 power of 28. Your area, no area here. Then the V we want to calculate. Then Q, V given. V is 1.3 times 10 power of negative 3. Then we want to calculate Q. That means that it must giving the area to us. We have to find it out. Where is the area? EMF 6.2. Area here, there. Cross sectional area. 7.2 times 10 power of negative 8. Okay. 7.2 times 10 power of negative 8. Okay, calculate your Q. This is just apply formula. There is nothing tricky. Just you need to find out where is your A only. Okay, because they didn't write it here, but confirm they were giving to you. So you have to go back and find. So Vashini give me the answer 1.1 times 10 power of negative 19C. Okay, this is the answer. So the most important actually is here. With reference to the value of Q, this value, explain why the data cannot be correct. So now the question tell you something wrong for the data here. So you refer to the Q that we get, why something wrong. How you know the something wrong? From this value, how I know that this data actually something wrong? How do I know? Any of you got idea? Correct, Wesley. Very good. Because previously when we learned about this formula, Q actually is a constant value. What is the Q value? I told you you have to memorize. Unless you go to the front page, the formula part, the information part there to get the Q. But I want you just remember about this Q. Q should be 1.6 times 10 power of negative 19. But from here, at the end, use the data and then we get 1.1 only. It's not 1.6. That means there's something wrong for the data here. Okay, so at here, the charge carrier charge carrier Q should have a charge of 1.6 times 10 power of negative 19C. So because of this, I understand this answer is not that good answer. So I can conclude that the data that they get is not correct, incorrect. If correct, I should get near to 1.6 times 10 power of negative 19 column. Or it will get exactly 1.6. Okay, is that clear? Okay, good job. Next week, I think I prepare another extra worksheets is regarding this chapter. Okay, so next week we do the self-practice lesson 42. We do it together, and then I will add on one more worksheet for you. One more worksheet I will prepare it, and then I will send out. Then I will label lesson 42B lah. Okay. So if no question, next week we do the overall this chapter revisions, past year questions. So you can revise first. Okay. For my worksheet is the 40. My worksheet at here is 39, 40, 41. 42 is self-practice. You study 3 worksheet and then I choose some past year question. We do it together. So you need to revise first, okay? So if there is no question, that's all for our lesson today.